Our next presenter is going to be Kevin Schmidt with Forecast3D. Kevin's presentation is going to be on high volume additive manufacturing. Kevin is a sales program manager who has focused the last 2 years on additive applications within the automotive and transportation segments. Kevin joins the Forecast3D team from GKN Additive, their additive division. Prior to the additive journey, he spent the last 10 years in various automotive roles, from after sales and service to product development and launch. Kevin graduated from Ferris State University with a bachelor's degree in psychology and in automotive management. He has a strong passion for motorsports and resides within the greater Detroit area. Kevin is no stranger to a hands-on approach with experience in a variety of production and custom fabrication methods. See, Kevin, are you able to join?
We'll be starting in about 1 minute.
Okay.
Okay, there we go. Looks like a little bit of a technological difference there, so no problem. Can you guys hear me?
That's okay. Welcome, Kevin. Glad to have you. I don't know if you caught it, but I did a quick introduction, and so I'll let you go ahead and take it away.
Sure.
All right.
Let's see. All right. So, thank you, Roxanne, introduction. Did able to catch that just real quick. We are representing what we have focused up here is going to be not only metals, but polymer. So I'm going to try and explain where maybe some of the differences are. My background here really focused from GKN Additive and Forecast3D. So looking at the two kind of companies in a nutshell, we have the GKN Additive side. This is from the GKN Powder Metallurgy group. So this actual company is made up of 3 divisions. We are unique in the sense that we own our own powder creation company. So not only does that mean alloys and additives, but as well as actual metal powder production. So this is a strong arm and kind of the GKN Additive team. The other aspect you see in the center, in the center is the center metal side. So this is the aspect of GKN that does day in, day out center metal activity. So this is a lot of compaction, high precision parts, still based in powder metallurgy. And where from the additive team is the kind of the third arm, or you could say the leg to this trio here. And within GKN Additive, we leverage our strengths from kind of mass production mindsets for the center metal side, but as well as leverage the knowledge and capability that we utilize with Huganis, who's our powder company that we have in-house. So across that, this powder metal is focused really across, additive and non-additive business as well. So looking at the forecast side, the acquisition of Forecast3D had taken place earlier this year in January of 2020. This is a company located out of Carlsbad, California. This is primarily focused on prototyping and had really got its start heavily into the silicone mold tooling, which you see as urethane casting. And as the years developed, the business grew, the demands for the business grew. There was a lot of technologies brought in-house to really support some of these quick-term prototyping, that were urethane casting, silicone mold tooling, whichever your preferred verbiage is. From there, there's been an explosion of different additive manufacturing machines, and they were able to acquire things like DMLS, the FDM, and up until recently, we've been really focused with Hewlett-Packard on bringing some of the MJF to scale and kind of a larger production run. So with the company that we have, we're used to 1 million parts per year. We're used to 1 parts per year. This is a very unique situation where we have the ability to kind of learn from each other's strengths and utilize that as one company. So the snapshot you're seeing right here is actually a shot of the production floor. This is one of the MJF rooms. So what does it mean to be in a high scale, high volume scenario? Well, if you ask anybody when it comes to volume production, high volume can mean different things in different places within different commodities. So what we leverage is our existing industrial and automotive footprint. So this is typically a global type commodity, regardless of the individual components. So for us in the North Americas, we have our plastic printing competency center. This is going to be in Carlsbad, outside of San Diego. We have our powder development center in Cinnaminson, New Jersey, and we actually make Ti 6-4 powder there on site. And I come from the Auburn Hills location, which has a mixture of metal and some planned growth for additional polymer machines throughout the year. So that's a real good snapshot of how we work just within kind of the NAFTA region, and we support the North and South Americas from these locations. But when we look at our GKN kind of partners, their focus is really stem from Germany. So we have a production site in Bonn, Germany, where there's multiple DMLS printers, as well as some conventional business when it comes to center metal business. Surrounding there, we have our Badlands Alza. This is a metal injection mold facility. So this is going to be kind of a key piece into the larger volume additive journey that we're taking place. Rotterdamwald, that's kind of a hard one to spell and pronounce, but this is our advanced process and R&D center located in Germany. So not only do we service the local German and kind of Northern Italian area that supports kind of the greater Europe landscape when it comes to supply chain, we also, as a global company, have facilities in India and China. And what we've done is used one of our compaction sites in Danyang, and we have added an additive center to this. So for a lot of people out there not familiar with powdered metals, this is very it can be very dangerous. It's very caustic. You want to be careful handling. So it's very important that we leverage the lessons learned and the knowledge we have with powder handling and just adding an additive center rather than having a complete greensfield site where you are just bringing additive, and to not have that background and understanding of safety is something that we are really pride ourselves on. So this is a snapshot of how we service globally. So you can call one of us up in Germany, you can call one of us up in California or Detroit. Someone across the time zones there is going to be able to support you locally. So that is something that we bring as kind of a key focus when it comes to high volume production. It's typically you're building a component that needs that volume. You might be across a global market. So this is something where we kind of use our vision. This is the core of GKN, is how do we bring new technologies to sort of a large scale production? How do we implement this new technology to be able to service things that we already do? So this has been really a core process for GKN, and with additive in the last few years, this has been really the new push. This is the new focus where we see the direction of our business in powder metallurgy. So because of that, we've learned a lot of things along the way when it comes to launch, scalability, quality, certifications. These are all core aspects of our day-to-day life, and that should be no different when it comes to additive. So taking a really kind of a look at what does the general production landscape look like? If you want to compare different technologies, there's a reason you stamp parts, there's a reason you cast parts, and et cetera. So from us, we look at the full value stream of the production life cycle, going from an early concept all the way up to millions of parts per year. You need to be able to pick the right technology for that right type of application. So with that, we've used additive in traditionally binder jetting and laser printing style to support a lot of the pre-series, pre-development concept. This is a lot of the early R&D steps where we have such great wins when it comes to additive. This is a great way to have like a smart launch is what you would call it. So to be able to plan your parts to launch correctly the first time, that will set you a leg up across your other suppliers. So to be able to know that you've built the production tool right the first time, that goes critical. So to be able to prototype that part before you even make the tooling, you can anticipate changes that you can incorporate while the tool for a production component is still being manufactured. But this doesn't only limit ourselves to pre-production only. There is opportunities for additive to be in a high production mindset. So it's really going to be focused on, as we get some of the education out there, there's a lot more exposure. People are getting more comfortable with it. We're throwing away a lot of the old ideas of when it comes to, I need to produce a part, but I can't get a bit in there, or I don't have a way to actually machine this. With additive, you're going to be able to see the benefit of using things that you can't make. And that will put additive in a great position when it comes to kind of scaling for production. So there's a lot of opportunities for new geometries, things like that. But as we see, every production life cycle has a decline. So you're going to start to, maybe a new model is going to replace it. It's going to make this obsolete. So you're going to see the orders fall off. You're going to see the volume disappear. This isn't going to be 1 million parts per year anymore. Maybe it's only 100. So with that, with additive, you're going to be able to focus your digital inventory, and by understanding the planning from your customers, you can predict and plan a pretty populated workflow to be able to keep the AM machines running at a production capacity. And not only does it limit yourself to after sales service, but as well into the aftermarket world as well. So there's going to be different, of course, requirements based on your customers, and it's always going to be best to take a minute, discuss, see if this makes sense. Use this as a proper tool in your toolkit. That's something I like to always encourage when we discuss with customers. So when it comes to scalability, we want high volume, but the process has to be able to be mature with it as well. So when we're talking specifically metal powder, there is a difference between the additive metal powder and the type of powder that you see in a traditional MIM or compaction type application. So if you even look at the photos here, the very left is a snapshot of the additive powder. You can see it's very spherical. This is, given the nature of the process. So is the water atomize, which you see here on the right. That is what we use in, day out for our compaction steels. So you want to be able to have these round shapes. You want it to be for precise welding. You want it for flowability. These features are not so easily done through water. When you go through a water atomization versus a gas or any other type of powder creation process, you can see the irregular shapes in there, and that does not spread well. You're not going to be able to get even particle distribution. It's not going to be the precision you need to be able to print additively. However, you can scale up these types of processes to be able to support 1 million parts per year. If you look at the additive side, this is only 1 to 3 tons per batch. That's a lot of energy. It's a lot of cost for not a lot of yield. Well, what if we could scale up to 55 tons at a time? So this is something that we are developing along with some guidance from some of the machine makers on kind of understanding maybe what is some realm of freedom that we can get as we tune the water atomized powders into a more of a spherical shape. So if we can have the spreadability, the consistency, the desired shape with using just water atomized process that we do in a large scale capacity, you're going to be able to get the economy of scale quite quickly. So this is also goes to show kind of the maturity level of the technology at the moment. We're not seeing people, filling up 55-ton vats every time to be able to make this additive powder. You're seeing it in much smaller quantities. So as the demand increases, as the popularity increases, the cost comes down with it. So this is something that we developed with GKN to be able to tune our water atomized process to make additive powders. So when it comes to the variety of serial production, I know a lot of people here aren't really focused on metals, focused on plastics. And for that, we've really had a lot of success with the HP technology. So this is going to be a lot of your nylons, polypropylene was just released, as well as TPU. So this is very interesting technology, and this is able to support a lot of low volume production type opportunities. But this technology is also what is going to enable metal at that same volume. So we've started off with DMLS systems. We use them in a variety of metals. This is a great foundation, and now we've matured. We're able to utilize what we can learn from the plastic side and how to extract parts, maybe what's a decaking process. There's a lot of similarities between the HP printing for MJF as well as the metal jet. So for us, this was a natural progression. We've used some other binder systems in the past, and we continue to do so. So with this kind of release of the HP metal jet pending soon, we've been their industrialization partner. So when I mentioned we had a metal injection molding facility in Bad Salza, Germany, we also have HP printers on site there. So not only are we able to validate how a batch furnace works with this process, but as well to think of more of a higher volume, a higher scale, and go to a continuous belt furnace like we do with a MIM master, or in general what we do with our compaction process on a daily basis worldwide. So for us, this is a partnership where we need to leverage each other's strengths. So Hewlett-Packard is really an industry leader when it types of printing various medias, 2D and 3D. With them, they approached us as the sinter metal experts to be their partner when it comes to metal jet. Forecast3D, we've been using MJF for a while. We're a major customer of theirs as well as the plastic side. So we get to see some of the kind of new materials release, what's in the pipeline, things that maybe we could get access to support our customers sooner than the open market. So for us, we've learned how to work digitally, but also how to kind of keep a traditional mindset when we want to be able to scale for mass production. And with that, we even see a lot of collaboration amongst ourselves, but with even the kind of the notion within the market. Competitors working with each other. They might not be direct competitors, but there'll be some overlap, things like that. There's a lot of open discussions happening on, and that's really just to progress the technology. So we've been, very hands-on and kind of scoping the market, using as a variety of technology that we can to support our customers. So for us, this is kind of the nature of the industry. And this is no different from our sinter metal days when we were just only a compaction part of the business. There's very often times we would be selling raw material to a competitor. This is kind of the backbone for us. So to us, this is business as usual. And collaboration is really what's going to drive from the raw material makers to the machine users, and the customers are ultimately using the end product. So I'll take a touch just to kind of explain the hardware that is really enabling high production volume. So from the MJF side, this is going to be plastic. So this is going to be a lot more of your some of your thermoplastics. They have to be a semi crystalline structure. So this works really well with your nylons, but does not work with maybe like your polycarbonates and your acrylics. So how this technology works is much like your inkjet printer. It is having a variety of inkjet nozzles on a print head that is spraying effectively this application agent onto the powdered media. In this case, it is a nylon 12 we'll use for an example. So what happens is, as the print head moves across the page, it is applying this glue to actually fuse the unbound powder together. But it needs a little bit of thermal help. So with that heat process, you're able to then apply the detail agent and then separate the areas that need to be bound versus the areas that need to be loose powder. So from there, then they go through their necessary post operations to whatever the customer's geometry is needed. So for us, this is how we're able to scale in a higher volume environment when it comes to additive. So the example I like to use is if you were to do this through, let's say, kind of like a laser sinter setup. If you wanted to write your name on a page, you're going to have that laser running the distance of your name. Well, with the printer, just the HP printer, you're going to be able to do that fairly quickly as well. But what if you want to do 10 of your names in one piece of paper, for example? That laser is going to have to run that distance. Whereas when it comes to this MJF setup, what actually happens is the heads of the inkjet printer are moving across the page regardless of how much content is on there. So if you have one name written on that page versus 10, it's going to print just as fast, whereas the laser is going to have to run the distance as if you were writing your name 10 times cursive. So moving on, the hardware has really grown and adapted and changed and has really turned into what we see today as the HP Metal Jet. So this is a very similar process in the printing aspect. What you have is powdered metal in this instance instead of powdered plastic. And from there, it is actually depositing glue that's actually going to be binding the powder together. And with that, there is some energy from the machine itself to be able to kind of bake the gluing together so that you're able to have what we call in the industry a green part. So the green part is about as fragile as a candy bar. You're able to hold it, but if you drop it, it's going to break. You can crack it with two hands. So with this, you have to be very careful to be able to remove the components from the powder itself. And there's a lot of opportunity out there for meeting automation to be able to support furnace. There's a lot of development going on with that through a variety of companies. So this is something where we see as kind of a necessary step to kind of help bring the volume to the application process. We need to be able to scale with the printing process. So with this, you have your printed part, you have it in a green state, you've successfully extracted it from the powder that is unbound, that is in the machine still. From there, you're going to do some final detail brush. It's going to be working like an archaeologist, ultimately before the part goes into the sintering furnace. And from there, it will shrink about 15 to 20%. So it's very similar to metal injection molding value stream, except it's not going through a caustic debind. It is doing that through the sintering process. So with this capability, you're able to then have a much more unique geometries. You're printing without support structures. That way, if you have furnace facilities and you can be able to attach this to support your core business, this is a great way to be able to leverage the existing infrastructure that you have in place. This is something that we see as a industry leader at the moment when it comes to binder jetting technology. So for us, we come from two different companies. We're used to prototyping with one hand, and the other we're used to high volume. But because of that, we've learned from each other's differences. And there's a lot of times when it comes to additive, high volume production could be just the quantity of prototyping. So we need to be able to digitize this. We need to be able to support this workflow. If you want the Amazon approach of kind of click, order, buy, ship, that is perfectly capable. We can handle that. There's a lot of instances where you need something a bit more in depth. You don't need just the click buy approach. You need a little bit more of, I need some guidance, I have some suggestions, or is there something with the topology that we can optimize to reduce the cost as well as improve the print speed. So with that, we take a more of a longer production type mindset where we want to understand what's the customer's qualifications. What are my checks that I'm going to have to do throughout the production process? Just because you're printing it doesn't mean that you get to throw quality out the window. It's actually quite the opposite. You still need to leverage a lot of the things that you learn from general production. These do still apply even though you're printing the parts. Maybe you've omitted some steps, so your quality guy has less work to do, but in the end, you need to be able to verify with your customer what is going to be the validation requirements and what is going to be the acceptance requirements of receiving the parts that you guys have agreed upon for this project. So with that, it really comes to feasibility studies. It's not just the printing itself and having passed the validation, but it's doing a stress test on the hardware as well. We want to be able to provide with confidence that we can repeat and reprint the order indefinitely. And that's where we come to kind of our core quality strengths is, having that focus, having that mindset for high production and just applying it to a different technology. So this is real similar to what I had discussed. If you're able to engage the customer, understand the requirements, go through and determine what is going to be the best tool in the toolkit that they need. For the example shown on the screen here, this is a great MJF one. How do we design a part that's optimized for the process, that gives the benefit of the process, but is not trying to copy something else? That is something that we get a lot is, could you make this injection molded part? Well, why? Well, what are your pain points? What are the issues you limit with? Given the technology, is there any type of premium that we can support in maybe an added benefit that would be too costly for an injection mold or a cast component, but provides a benefit when you're done in an additive mindset? So we always take care of the full value stream when it comes from early customer engagement, developing the parameters for their components, and to be able to really all the way through any of the cosmetic or functional finishing that may be required on the part before shipment. So this is always a balance. Just because you can print it doesn't mean that you always should. Is there a limitation that you need for the mechanical properties? A lot of times these are just issues that are on a piece of paper. There's a lot of times where you can see, well, maybe you don't need this grade of steel. What if we went to an aluminum, but we can, offer a different geometry, things like that. So it's to get the best part, you have to balance what you want, going from accuracy to performance, cosmetic. You want to be able to understand the scope of the project. Is this going to be in a Class A environment? Is this going to be in a Class B environment? Is anybody even going to see this part? Those are things that you can, take in consideration so you're not pushing your project deliverables out. So with, either company, we're focused on a APQP. We want to be able to have the right launch, using the right skill set to be able to deliver the project that we quote on. So a lot of things, challenges. What kind of perception do we have with the customer? Is this new technology for them? Maybe they're hinting at buying a machine. They need to get their feet wet. We're used to every aspect of the customer. some customer processes might not be additive friendly. It's how do we support them in supporting themselves? This isn't something that's necessarily limited when it comes to the physical parts. This could be a systems question. As mentioned before, it's finding the value in complexity. That is really tied hand in hand to the acceptance of it as well. So it's how do you understand, why am I doing this for additive and why does it make the most sense? And that's going to be the best home run situation when it comes to these types of applications. So for us, we really focus on the whole customer experience. We come from a craftsmanship background, but we also have a world-class production mindset. So for us, how do we capture that? This comes through our quality system. So we're meeting in the middle from high volume, low complexity to low volume, high complexity. What we're able to do is just use this as an opportunity to even test our own systems. Can we still apply our existing quality structure to these new processes? And then taking it one step further is, how do we digitize it? What we've been able to develop is to understand kind of like a visual shop floor that we have through our Advantage system. And with that, we are able to monitor live KPIs from the machines, understand, and be able to help planning when it comes to production capacity. So for us, this has always been kind of hand in hand. We like to think from an empirical mindset. If you have a quality concern, you need to have data and let the data do the talking, essentially. So with the systems that we have created to support, I can log on from my computer here in Detroit and I can see the printers operating in Bonn as we speak. And I can understand maybe if one is down or under maintenance and how long that is planned for. So that is one aspect of it, but this also kind of ties into the ERP system as well. So not only is it production planning, not only is it quality, but as a way for customer interface and be able to track payment. So that's one aspect. You can always go back to the click buy approach. We've done that as well, and that's where we have Instumental. That's a drag and drop instant quoting. This is something that's available for small companies, large companies, and anyone in between, end user as well. So with that, this can give you a great kind of budgetary mindset on maybe this part makes sense for additive, or maybe you can do some checks on some easy kind of feasibility. Does this wall thickness make sense? A lot of kind of early first steps when it comes to designing a part right the first time. So with those systems, this is really tied to each facility globally. So not only can I take a look at this facility in Germany, but I can also take a look and see how production is going in China. So from there, it's a little.
Hey, Kevin, we need to start wrapping up. Okay.
Sure. Kind of moving forward, I'll take this next slide a little quickly. When it comes to the forecast side, it's very similar. They've developed their own software and we're integrating the two together. This can be a click buy approach for you as well, where you may have minimal contact, but it also has plenty of options for you to kind of raise your hand and get some more attention within the company to be able to say, hey, I don't need 5 of these now. I need 5,000 and I need them every month. That starts the conversation. And we have the ability to track that within the actual dashboard system for Forecast. So anyone can sign up. You can go on Forecast3D.com and you'll be able to create your own dashboard account and you can start quoting and uploading files immediately. So for us, what we bring to whole is to say, maybe you want to start prototyping. That's great. But ultimately, you still want to use additive. Well, let us help you through the journey to be able to try dedicated trials for you to get you the most understanding out of the process and to be able to give a path towards production. Not everything needs to be injection molded. Not everything needs to be cast. There are plenty of opportunities where you can cater the part to your needs. Any questions?
Perfect. Thanks, Kevin. We're a little bit over time, so I tell you what we're going to do is we're going to send you the questions from our Q&A session or the Q&A
Sure.
panel so that you can reply to the various participants in one of the virtual networking sessions and or maybe afterwards with them directly. Okay.
Sure, absolutely. A great way to reach me is Kevin@forecast3d.com.
Perfect. Thanks, Kevin. Thanks, everyone.
All right, thank you.